this Boolean function has 3 variables. So I'm using a Karnaugh map made for 3 variables. So here we do the first one. The first one is where x is 0, y is 1, and z is 0. So I find that on the Karnaugh map. X is 0, y is 1, and z is 0. So it's right there. Oops. Okay. The next one is where x is 0, y is 1, and z is 1. So that's right there. The next one is where x is 1, y is 0, and z is 1. So x is 1, y is 0, and z is 1. The next one is where x is 1, y is 1, and z is 1. So they're all 1s. That's this box right there. Okay, so we've done step 1 is map the Boolean function onto the Karnaugh map. And we've done that. Our next one, oh, did I miss one? Oh, I am missing one. 1, 2, 3. Which one did I miss? 1, 0, 1, 0, 0, 1, 1, 1, 0, 1, 1, 1, 0. That's the one I'm missing. Where x is 1, y is 1, and z is 0. That's this one right here. Oops, got to get them all. And notice it was an easy count. I just had to count the number of 1s. There's 5 in the input table, and so I need 5 in the Karnaugh map too. They'll match, right? So you can catch those kind of mistakes. All right, now I want to pick the biggest groups. Now this is the first time we've had a group of 4. So notice here that what we've got is a group of 4. So let's make that a group because we want them as big as possible. And now we have this 1 out here. But notice how it could be 1, but we want to make our groups as large as possible. So it could be a group of 2, right? It can't be a group of 4 because there's a group of 3 there, and 3 is not an allowed size. But it could be a group of 2. So we wanted to make it as big as possible. So we'll make that a group of 2. So there's our 2 groups. All right. So step number 3 is to write the expressions that go with each group. And so if we look at this group of 4, we see that x changes. Sometimes it's 1, sometimes it's 0. So x changes. We look at y. Y stays the same. It's 1 in all cases. So we're going to for sure use y. And then z changes. So we're not going to use z. So the term actually is y. So for this group of 4, the term is y. Now, for this group, we see that x stays the same, so we're going to use x. And y changes. So it's a 0 and a 1, so we're not going to use that term because it can be either. And then z stays the same. It's a 1 in all cases. So we're going to write a z. So those are our terms for our 2 groups, and we connect those with an addition operation. Let's go ahead and compare that. And sure enough, there we have y plus x times z.